So, a flying disk of radius r moving with a constant speed v naught along the curve. Any particle is moving along a circular path is subjected to some force. So that force is centripetal force. Here you have a disk of mass, let us say m. Centripetal force will be towards the center. So it is moving with a speed v naught along the curve. So centripetal acceleration will be v squared by r, that is v naught squared by 4r towards left. At the same time, disk is rotating uh, with an angular velocity about its center perpendicular to the plane. So once disk is rotating about an axis which passing through the center with an angular velocity omega, then it is also subjected to a force, centripetal force. Set A, acceleration will be towards right, that is v squared by r, or r omega square. Here, omega here is nothing but he given it as omega naught square by 2r, that is 4r square, which we get v naught square by 4r, that is towards right. So acceleration of point A at instant with respect to inertial frame. One is due to self-rotation about its axis, that is v naught square by 4r towards right. Other is, it is at the same time moving in a radius 4r. So that because of that, acceleration will be towards left, v naught square by 4r towards left. So the net acceleration will be 0. Fourth option is correct. Here, OPQRO is a current carrying loop and I current passes through it. The semicircular section of radius A lies in XY plane and another part in YZ plane. So once loop is a current carrying loop is placed in a magnetic field, it experiences a torque. The torque is calculated by using a formula m bar cross b bar, where m bar is magnetic moment. So which is defined as I times a bar. So here direction of magnetic moment. When current passes through this semicircular wire OPQ, put thumb in the direction of current, curl the fingers. That fingers, the direction of magnetic moment is the direction of fingers. That is here magnetic moment direction is along the direction of m bar is along positive z axis. So then torque will be I a bar. It is a semicircle whose area will be pi a square by 2, and that is magnetic moment direction, area direction of one and the same. It is along z-axis k cross b bar. Magnetic moment, uh, magnetic field, he given it as root 3 b naught, and that is along positive x-axis root 3 b naught I. So root 3 b naught pi a square by 2 I, and k cross I is nothing but j root 3 pi b naught I a square by 2 j. So fourth option is correct. Here, a longest straight carrying conductor is placed here. Long straight current carrying wire of current carrying current I is lying along the axis of a long thin walled hollow cylinder. The cylinder is carrying a current I by 2 in opposite direction as that in the wire as shown in the figure. The magnetic field as a function of distance. Okay. So here this problem is solved by using Ampere's law. So what Ampere's law states? Here integral B dot dl, which is equal to mu naught I. So here once current passes through this wire I, magnetic field is along this direction, dl also in the same direction. So B times integral dl is mu naught I. Suppose here by using this Ampere law, he is asking magnetic field as a function of radial distance. Suppose you take a point here. So here take the closed surface that is having radius r, where r is less than r. So then integral b dot b integral dl becomes 2 pi r, which is mu naught I. B will be mu naught I by 2 pi r for r less than r. Now, for r greater than r equal to, so here b times, even here if you take for r greater than r, mu naught b into 2 pi r, which is mu naught. I current is in upward direction, I current is in downward direction. B into 2 pi r will be mu naught I by 2. So B here is mu naught I by 4 pi r. So this is outside or on. Here it is inside. So here it is mu naught is mu naught. The current which passing 4 pi all are constant. That B is inversely proportional to radial distance. It is like y equal to 1 by x. The curve will be like this. So suitable curve will be here. Magnetic induction and here magnetic induction are different. So this can't be the answer. This can't be the answer. Both are inversely proportional to R. C is correct answer. At this point, magnetic field is mu naught I by 2R. At this point, magnetic field is mu naught I by, here it is 2 pi R. Here it is 4 pi R, which is less than that. Here, this figure, a stream of liquid is emerging from a tube in the base of an open tank. The maximum height attached height attained by the liquid jet. This problem can be solved by using Bernoulli's theorem. Take this as a reference level. So what we know in Bernoulli's theorem, so here pressure plus half rho v naught rho v square plus rho GH is constant. If you take this as a reference level, at this point, here it is atmospheric pressure. Let us say when liquid emerging out of a tube with a V1 velocity, when it reaches this point, V2 velocity, initially reference level is this 0, P naught plus half rho V2 square plus rho G Y. So this get cancelled. So Y will be V1 square minus V2 square by. So once it rises with here V1 velocity at this point, so V at V2, its velocity is only V1 cos theta. That is V1 square minus V1 square cos square theta by, here it is 2. So V1 square into 1 minus uh, cos square theta, which is sine square by theta. So, so here V1 square is nothing but, so 0 plus your initial velocity 0, it is 2gh. V1 square is, that is 2gh by 2 sine square theta. Here it is g will be there. So what we get is y here is h sine square theta. Or we can take at this point its velocity is root 2gh. So with that velocity it attains a maximum height. Y is equal to u square sine square theta by 2g, 2gh sine square theta by 2g, h sine square theta. Here it is. So here, three identical metallic plates are kept parallel to one another at a separation of A and B. The outer plates are connected by a thin conducting wire and charge Q is placed on the central plate. So here you have, so the charge is distributed along the inner surface, let us say Q1, Q2. Once charge Q1 is uh, on plate 3, minus Q1 will be induced on it. And since charge is conserved, initially there is no charge on the first left plate. So the total charge must be 0. Similarly, on the right side plate, uh, no charge. Here minus Q2 is induced. So total charge on it will be 0. And here it is. This one is one capacitor whose capacitance is A epsilon naught by D. That is A epsilon naught by A. So this one is another capacitor C2, which is equal to A epsilon naught by B. Because they are identical metal plates, so cross area will be same, but capacitances are different. So when they are connected, so here when they are connected by a wire, this wire, so potential will be same. Both capacitors are connected by a wire, so potential difference is Same. That is Q here is CV. So once V is same and Q by C is constant, Q1 by C1 is Q2 by C2. So Q1 by Q2 will be A epsilon naught by A by A epsilon naught by B, which is B by A. A Q1 will be B Q2, but total charge Q1 plus Q2 is Q. So Q1 here is B Q2 by A plus Q2 here is Q. Q2 will be A Q by B plus A. But what he asked, charge on 1, that is Q1. Okay, Q1 will be uh, B by A Q2, that is B by A. Q2 will be A Q by B plus A, which is B Q by B plus A. Right? So charge on Q1 is BQ by A plus B. At the same time, charge on third surface. Third surface is also same. So either first option or third option. Um, now, fifth one is minus Q2. Q2 is this, so third option is suitable. Here, PV diagram of a cyclic process ABC and choose the incorrect statement. So let us take different parts. In first B to C, if I consider, their pressure is constant. Pressure constant means PV here is nRT. V becomes proportional to T. Since volume from here to here, it increases. So volume increases, which implies temperature increases. Internal energy is a function of temperature, which implies delta U in B to C is positive. But he is asking for incorrect option. This is correct option. And let us take C to A. In C to A, volume is constant. Volume is constant means work done is 0. So delta U, delta W will be delta Q plus delta Q here is delta U plus delta W. Work done is 0. Then delta Q will be delta U. So, so volume is constant, pressure increases, temperature increases, which implies delta U from C to A is positive. So incorrect statement, only single option is there. Third option is correct. But to understand remaining, so delta Q from A to B. So why it is negative? Let us see here. From A to B. So here volume is this much. At this point, volume is this much. At this point, pressure is this much at this point. Pressure as well as volume decreases. Pressure and volume decreases. Volume decreases. Temperature here. Pressure decreases. Volume decreases. Temperature decreases, which implies internal energy decreases. So delta U from A to B is negative. So delta Q we have to find out. Delta Q is delta U plus delta W. So here delta W also from A to B is negative as volume decreases. So delta Q will be obviously negative. This is also correct option. So in CAB process, work done is as volume decreases, obviously work done is negative. Here in this question, acceleration of the wedge of the mass 5m. So I'll solve this problem with respect to the center of mass. Let us assume initially just before sliding, center of mass is here. So once it's starting, 2m starts sliding downwards. So here m starts moving towards left. So when m starts moving towards left, so there is no external force, center of mass will not change. So here it moves by a distance x. So this also string moves up by x, but horizontally, how much? Here it is 60, this is 60. So it will be x cos 60, which is x by 2. So here it is, m mass moves towards left by x units. 2m mass horizontally, it moves by x by 2, 5m mass x2. But there is no external force. So center of mass still remains at the same point. Here mx minus mx plus 5mx2. That means x2 is 0. Net displacement 0. So acceleration of wedge 5m is 0. Here the equation of a vibrating string fixed at both ends is given. So stationary wave equation A sin kx omega sin omega t. So he is asking speed of transverse waves, nothing to do with number of loops. So V here is omega by k. Omega is 400 pi by k value is pi by 15. That is 4 into 50, 60 into 100 centimeter per second, which is 60 meter per second.